Nitrous oxide is commonly known as laughing gas because inhaling it causes laughing human face by the effects of anesthesia. It accounts for about 6% of anthropogenic greenhouse gas, as shown in the results of various investigations. Nitrous oxide is generated in the atmosphere by the Earth's nitrogen cycle and several natural elements. The concentration, however, increases every year due to the artificial factors such as agriculture, combustion of fossil fuel, wastewater treatment, and industrial activities. The lifetime of nitrous oxide in the atmosphere is about 120 years, and its global warming potential is 310. The abatement techniques of nitrous oxide include pyrolysis, catalytic decomposition, and electrochemical method. To reduce nitrous oxide, our center has developed remarkable solutions with the following research fields: fluidized bed materials and fluidized bed combustion processes to suppress nitrous oxide emissions, catalyst and combined treatment process for reduction of high-low nitrous oxide concentration, diesel after-treatment system to minimize nitrous oxide formation, technology for the recovery and purification of high-purity nitrous oxide from industrial emission gases. Development of fluidized bed materials and fluidized bed combustion processes to suppress nitrous oxide emissions. Even though nitrous oxide is one of main greenhouse gases, conventional sewage sludge incineration systems do not include nitrous oxide abatement technology and thus have released a large amount of nitrous oxide. We have developed a new incineration system, suppressing nitrous oxide emission as well as fluidized bed materials as a catalyst to decompose nitrous oxide at high temperatures in an incinerator. Sewage sludge fed into the system is incinerated by heating up with the fluidized bed material and mixing with the combustion air. Unburned gas generated in the fluidized bed is completely incinerated in the freeboard. While the conventional systems utilize sand as a fluidized bed material, our system uses a specially designed catalyst to remove nitrous oxide and reduces nitrous oxide emissions. Moreover, special nozzles installed on the air distribution plate can improve the mixing efficiency of the dried sewage sludge and prevent local overheating. The newly developed catalyst with high mechanical strength consists of highly active components in nitrous oxide abatement. When ash of the sewage sludge is discharged from the bottom of the fluidized bed incinerator, a catalyst separation device recovers the catalyst for reusing. In addition, the enhancement of combustion performance can be achieved by increasing the mixing rate of combustion gas with the secondary air injection at high speed. The incorporation of the developed fluidized bed incinerator into a sewage sludge drying system enables stable treatment of sewage sludge at low cost. The developed incineration technology using a highly efficient nitrous oxide decomposition catalyst as a fluidized bed material can reduce nitrous oxide in the incinerator without an additional installation of a post-treatment facility. Furthermore, high decomposition temperatures can minimize the deactivation of the catalyst in the presence of acid gas, such as sulfur oxide. The newly developed fluidized bed material and fluidized bed incineration system to suppress nitrous oxide emissions accomplishes 90% of nitrous oxide reduction and 85% of catalyst recovery. Development of catalyst and combined treatment process for reduction of high-low nitrous oxide concentration. Nitrous oxide is not harmful to human body, but shows 310 times higher global warming index than carbon dioxide. The main sources of nitrous oxide emissions in industrial processes are a chemical process emitting high-concentration nitrous oxide, a combustion process emitting low-concentration nitrous oxide, and semiconductor and display processes. Recently, nitrous oxide emissions have been increasing day by day due to industrial development. The emission characteristics of nitrous oxide vary widely according to each industrial process, and nitrous oxide is generally emitted together with nitrogen oxide. Our technology is the process to treat nitrous oxide using catalyst technologies and has the advantage to reduce nitrogen oxide together. Based on these core technologies, we are able to provide the optimum abatement process suitable for the emission characteristics of various industrial processes. Unlike conventional processes to reduce nitrogen oxide and nitrous oxide in two phases, our technology, which is applied to the chemical processes where nitrous oxide is discharged at high concentration, minimizes facilities as it can simultaneously process the two phases in a single reactor, using a single catalyst and a reducing agent. In particular, compared to conventional catalysts operating at high temperatures, the operating temperatures have been closely reduced to the nitrogen oxide reduction temperatures, which can greatly contribute to energy saving. Based on the current basic research, we have developed a chemical processing commercial plant with a capacity of 1,000 normal meters cubed per hour. We have achieved excellent nitrous oxide and nitrogen oxide removal performance of 95% or above through demonstration operation of nitric acid production process. The combustion process has larger exhaust gas flow rates than other processes and contains a large amount of catalyst poisons. We have developed a honeycomb-type catalyst suitable for the characteristics of combustion exhaust gas and have enhanced the durability of catalysts against poisonous substances. As exhaust gas emitted from the electronics industry contains dust and acid gas, it is very difficult to apply nitrous oxide abatement technology. The nitrous oxide abatement process for the electronic industry consists of a pre-treatment process and a catalyst reduction process. Dust and acid gas are removed in the pre-treatment process. Nitrous oxide decomposition catalysts, considering the characteristic of fluctuating concentrations of nitrous oxide, boast more than 80% removal efficiency at 350 degrees Celsius or less. Nitrous oxide nitrogen oxide abatement process that shows superior performance over advanced technologies has reached commercialization to visualize business. Our technology can replace nitrous oxide technology, which is dominated by developed countries with pure domestic technologies, and make national interests by expanding its business into overseas markets. In addition, the technology can greatly contribute to reduction of domestic greenhouse gas emissions, as it is possible to preempt the nitrous oxide market by securing an original technology in the unexplored fields, such as the combustion process and the electronic industry. Development of diesel after-treatment system to minimize nitrous oxide formation. Considering nitrous oxide abatement technology to cope with nitrogen oxides regulation of construction machinery and agricultural machinery, except automobile, a leading technology of new concept exhaust gas treatment. Our technology meets the off-road emission regulations that have been in force since 2015. The microporous titanium dioxide modified by hydrothermal synthesis and the zeolite catalyst prepared by controlling the ion exchange ratio and mixing the specific ratio are applied to suppress nitrous oxide generated in the exhaust gas treatment without additional equipment. We have developed the microporous titanium dioxide with high ammonia SCR stability and nitrogen selectivity at high temperatures and applied it to meet the off-road Tier 4 regulations. And we have reduced nitrous oxide emissions by 1/3 compared to after-treatment equipment. We have developed a reaction model to convert urea to ammonia according to the mixer and vane shape. We have designed and developed the urea dosing control unit by engine load and the after-treatment applications. The newly developed nitrous oxide abatement technology satisfies Tier 4 regulations and effectively suppresses nitrous oxide produced in after-treatment system. Development of technology for the recovery and purification of high-purity nitrous oxide from industrial emission gases. This technology of recovering high-purity nitrous oxide can reduce the emission of nitrous oxide, which is a non-CO2 greenhouse gas, and abate global greenhouse effect by recovering high-purity nitrous oxide of 99.999% from emission gases of adipic acid or nitrous oxide manufacturing processes, which contain 30 to 50% of nitrous oxide. High-purity nitrous oxide, recovered, can be used for semiconductor and LCD manufacturing processes as an oxidizing agent and for medical anesthetic. The high-purity nitrous oxide manufacturing process under development in this research consists of pre-treatment process to remove dust and carbon dioxide contained in emission gases, membrane separation process to concentrate emission gases containing 30 to 50% of nitrous oxide into about 90%, and low temperature and high pressure distillation process to recover high purity nitrous oxide of 99.999% from the gas mixture concentrated by membrane separation process. The technology of recovering high-purity nitrous oxide is not commercialized yet worldwide, and we are developing the technology for the first time in the world. This is the detailed design, drawing of the low-temperature and high-pressure distillation process under construction in the first year of this research. The construction of the low-temperature and high-pressure distillation process to recover high-purity nitrous oxide of 99.999% from the gas mixture containing nitrous oxide of about 90% is currently underway. We have a plan to complete the construction of the pilot plant for recovering nitrous oxide, including the pretreatment and membrane separation processes, by the second year of this research, and to develop the optimized purification process technology through the operation of the pilot plant in the third year. The recovery process of high-purity nitrous oxide, which we are developing in this research, can generate emission gases containing nitrous oxide of about 1 to 5%. To prevent air pollution due to these emission gases, we are simultaneously developing a thermal decomposition technology of nitrous oxide with high-frequency induction heating. The thermal decomposition technology can reduce the concentration of nitrous oxide of the emission gas to less than 100 ppm by decomposing nitrous oxide. This thermal decomposition technology with high-frequency induction heating, which we are developing in this research, is the first one in the world, and we will be able to have international patents. By applying the technology developed in this research to domestic industrial emission gases, nitrous oxide of a non-CO2 greenhouse gas can be recovered and reused in the industry. Through this, we can reduce about 9 million tons carbon dioxide of greenhouse gas emission annually, and expect the increase of annual sales of more than $17 million. In addition, we can lead the technologies of recovery and decomposition of nitrous oxide by developing both the process technology of high-purity nitrous oxide recovery and the thermal decomposition of nitrous oxide with high-frequency induction heating for the first time in the world.